All right. Okay, so this morning we're talking about permissions. So we're in the file permissions notebook, if you're following along. All right, so Unix was designed as what's called a multitasking, multi-user operating system. So that means that it supports multiple users being logged into the same, I guess, computer at the same time. Right, so you have multiple users. It's also multitasking, so that means that it supports multiple tasks running on the same processor at the same time. Well, it provides the illusion of multiple programs or tasks being run at the same time on the same processor. Right, so typically, so back in the day, so many, many years ago, when people didn't have desktop computers, what would happen is you'd have, your company would probably buy one large computer somewhere, possibly running Unix. Right? And so the way that ordinary users would access the computing system is via the network. So you would have basically a screen and a keyboard, but all your compute would actually happen somewhere else. Right? So you'd be remotely logged in on a server somewhere, and all the people would be working on the same server. Right. That still happens today, although usually what happens, usually when you remotely log into a system, because computing is so cheap now, people generally have computers on their own desks. But it's still common that if you're running some very large network-based system, like Netflix or something like that, or Amazon or Google, right, you might have hundreds or thousands, tens of thousands, hundreds of thousands of servers. Right? Obviously, you're not going to hook a computer monitor and keyboard up to every one of those computers. Right? And so typically what happens is you remotely log in to one of those servers. All right, now if you've got multiple people accessing the same system at the same time, right, you need some way to organize everything, right? So you need to keep each individual, well, you'd want to keep each individual's users' files in their own place, right? You want user A to control user A's files, you want user B to control user B's file, and so on and so on and so on, right? Similarly, you don't want normal users to be able to modify the operating system files. Okay. And so Unix has this relatively crude system of setting up what are called permissions. And so permissions are granted to 3 different classes of users. Right? So there's something just called the user, right there. Right? So the user is someone who owns a file. Right? So in other words, every file has associated with it a username. Right? And so Burton owns file a.txt, somebody else might own file b.txt, and so on and so on and so forth. Right? Typically, the user owns their own home directory. Right? So on my computer, I own the directory called Burton. Then there's the notion of what's called a group. Right? And so someone, not a normal user, but someone can take people, ordinary users, and organize them into separate groups. Right? So that in our department, there might be a group called UGrad for undergrad. Right? There might be a separate group called grad for the grad students, and then there might be a group called faculty for faculty users. Right? And then there'll be another group above that called admin, and they're the people who have administrative privileges over the operating system. So in Unix, every user belongs to at least one group. Right? And typically, a user belongs to many different groups. Right? And so Unix and Linux use this notion of a group to grant permissions to users for certain services. In modern Linux distributions, a modern Linux distribution usually creates a group for every username. Right? And so you'll see on my computer that there's a group called Burton, and that's the group that consists solely of me. And that's just the way that modern Linuxes work. Right? Every file also has a group name associated. Right? So every file is owned by a user, and every file also is owned or belongs to a group. Right? And then finally, there's the class other. That's everybody else. Right? So everybody that's not everybody who's not the current user, and everybody who's not in the group, that's the group of everybody else. Right? So they're called other. All right, so we're going to be working in this directory called permissions. Oh, does that work? Here we go. Oh, I guess I'm already there. Hopefully I'm already there. Hang on just a second here. Yeah. Okay, So let me just check if the notebook's actually in the right directory. Oops, sorry. Yeah, okay. I don't know why it keeps on telling me that. All right, anyway, it's fine. Okay, so if you want to find out information about groups, then the easiest way to do that is to run ls with the long listing. Right, so minus L, right? Minus L, not minus 1, right? Minus 1 lists everything in one column, every file on one line. Minus L gives you the long listing format. Now, typically you see something like this, but it doesn't always look like this. And does this scroll? No, okay. Right? So the long listing format is not standardized, but it typically looks something like this. Right? So the first thing you see are some letters or symbols, and they are 3, 6, 9, 10 of them? I think it was 10 of them. Right? So in this case, you see dash, RW, dash, RW, dash, R, dash, dash. Right? And so the first thing you see there, those are the permissions. Right? So the leftmost symbol is the file type. So if you see a dash, it's just a regular file. If you see a D, it's a directory. Right? Everything else, so the RW dash, RW dash, R dash dash, those are called the permissions on the file. Right? So they're the permissions on file 1. Number 2, don't worry about that. It's something called the number of hard links. We're not really concerned about that this year. Right? sys220, there's the username, right? And there's the group name, sys220 as well, right? So these are actually distinct, right? That's the username, that's the group name. Because this is done on a Linux operating system, there ended up with being a group having the same name as the current username. Right? File is the size of the file. The next is the modification or timestamp, the modification date, and then finally the last part is the file name. Right? And so this is the part we're interested in today, this stuff over here. Okay, so that leftmost group of symbols, those are the file type and the file permissions. Right. The file type, so almost always you'll see a hyphen as the first symbol, so that indicates that it's a regular file, or you'll see a D, which indicates that it's a directory. Right, so let's just pop, into, no, wrong one, terminal, okay. Okay, so I'm in the permissions directory. Oops, sorry, minus L, right? There's only one file here, right? And it's a regular file, right? That's what the first hyphen means. If I go up one directory, right, list everything. You see there's a whole bunch of directories here, right? You'll see that the first symbol changes to a D, right? To indicate that all of these things here are actually directories. There are other symbols as well, right? There's something called a link, but I skipped over that part in one of the notebooks, so we're not so worried about that. And then there's C and B, and there's some other symbols as well. Right? You won't see C and B unless you're poking around in your operating system files. Right? Those correspond to, well, C corresponds to what's called the device file, so it's a character special file. Right? So if you actually find the file that corresponds to your terminal, it's going to have a C beside it as the file type. And then there's something called a block special file. So if you look for your hard drives, there's a file associated with them. There will be a little B beside it. But the part we're really interested in are these permissions. Right? And so there are 3 groups. So there's a total of 10 symbols here. Right? If you ignore the first one, there's 9. So they're divided up into 3 groups of 3. Right? So remember, we have 3 different classes of permissions. Right? We've got user, group, and other. And so that's what these correspond to. Right? Okay, so the first 3 symbols, in this case the RW and the minus, those are what are called the user permissions on the file. Right? The next 3 are the group permissions, and then the last 3 are the permissions belonging to every other user. Right? So current user, current group, current user, the group that's associated with the file, and then everybody else, right, is how you read that. So R means that whoever the group, whatever the, class of user is, they have what's called read permission on the file. Right? So that means they can read the contents of the file. Right? The W indicates that they can write to the file, right? So they can overwrite the contents of the file. And then the dash means they do not have permission on the file for that particular thing, and that's called the execute permission, right? Oh, sorry, cell. Right? So if there is an X here instead of a dash, that means the file, the user has execute permission on the file. Execute permission means that the user can treat that file as though it were a command, right? So in other words, it looks like an executable program, right? You can set that permission to X even if a program is not executable, right? So you can take a regular file, set the execute permission on the file, and then pretend that it's a regular file or program that you can run, right? When you go to run it, it may not work, right? But you can still give it permission to the user to treat it as though it were a regular command. Okay, so hyphen means that particular permission is not granted, right? RW or X means that permission is granted, right? So in this case, the user has read-write permission on the file. They do not have execute permission on the file. Right? The group has read-write permission on the file. They do not have execute permission on the file. And everybody else can read the file, but they can't write the file and they can't execute the file as a command. And so permissions can affect both a regular directory and a file. Right? And so the meaning of read, write, and execute are different depending on whether or not the thing is a regular file or if it's a directory. Okay, so if it's a regular file, then giving read permission to the file means that the file can be opened and read. Right? So in other words, you can access the file and look at its contents. Right? If you have write permission on a file, that means that the file can be written to or truncated, so meaning delete the contents of the file. Sorry, sorry, I shouldn't use the word delete. So it means you can write to the file or you can remove the contents of the file, but the file still exists. Right? Now the weird part here is that even if you have write permission on the file, that does not mean, right, that you can delete the file or rename the file, right, or create the file. Right? In order to do those sorts of things, you need permissions somewhere else, and we'll get to that in just a second. Right? And then finally, if you have execute permission on the file, then you can run that program. You can treat that file as though it were a regular program. You can try to run it as a command. Right? So that's if it's a regular file. Now, if it's a directory, these mean something slightly different. Right? So if a directory has read permission, right, that means that the user can list the contents of the directory, right, as long as the directory also has execute permission on it. Right? So you need both read and execute permission in order to list the contents of a directory. Right? If you have execute permission on the directory, then you can change directories into that directory. Right? If you don't have execute permissions on that directory, you cannot change into that directory. Right? And then finally, if you have write permission on a directory, right, now this is where you can create a file, delete a file, or rename a file, as long as you can also enter the directory. Right? So typically to do something in a directory, you also need execute permission. That's not always the case, right? So you can still read a file even if you don't have execute permission on that. Is that true? Sorry. You can read a file as long as you have execute permission, even if you don't have read permission on a directory. Right? So if you have a file inside of a directory, you may not be able to list the contents of a directory, but you can still read files that are in that directory as long as you can move into that directory. Right. All right, so the write thing is weird. Right? So if you have write permission on a file, you might think that I ought to be able to delete it. Right? Okay, so let me make a directory called temp. Right? So on temp, I have read, write, and execute permission on that directory. Right? Okay, so inside temp, I'm going to make a file, some file. Right? So in temp, there's some file. I have read, write permission on some file. Right? So I'm going to add some stuff to some file. So I'm going to cow say hello. And I'm going to redirect the contents to some file. Right? If I look at the contents of some file, right, I've got something in that file. Okay, So let me go into temp, right? And let's just quickly review what we have here. I've got some file, it's got something in it, right? So it's not empty. I currently have read and write permission on that file, right? If I take away write permission on that file, oh wait, so some file. Okay, so I just made a copy of, oops, sorry. Okay, I just made a copy of some file using CP, right? I'm now going to remove some file, and that works. I list the contents of the directory, and some file is indeed gone. Okay, so I'm going to restore some file just by using copy again. So I'm going to copy the backup onto the original, and now it's there. I'm now going to strip off write permission on some file. Right. So I'll explain this command in just a second. Right. So notice on some file, I no longer have write permission on that file. I can still read it. So if I do cat, I can still look at the contents of the file. Right. I can't write to the file. So if I try to append to the file, hello again. So double greater than, right? So I'm going to try to append to the end of some file, right? It complains, right? It says permission denied, right? Why is it denied? Because I don't have write permission on that file, right? Can I rename the file? Right, so, sorry. So can I rename some file, right? Now remember, I don't have write permission on the file, right? But I can rename it. So I can move some file to some other file, and that works. Right, so some file's gone, but it's now renamed some other file, right? Some other file, the permissions don't change, right? So they retain their permissions. So even though I don't have write permission on the file, I can rename it, right? And so you might ask yourself, well, why does Unix or Linux let me do this, right? And so you have to remember, where is the name of a file kept, right? The name of the file is not kept with the file itself, right? It's kept in the directory containing the file, right? So remember, a directory is just a listing of file names. Each file name is mapped to an inode, right? So you need write permission on the directory to change the file name, right? The file name is stored in a file called a directory. Right? So you have to be able to edit the directory in order to edit the file name, right? You need to be able to write to the file in order to edit the contents of the file, right? So the name of a file is not the same as the file itself, right? They're not kept in the same place, or they're kept in different places, right? In order to change the file name, you need write permission on the directory, right? So if I take away write permission on the directory for myself, sorry. So ls minus l, oops, sorry, al, right? So on dot, right, I have write permission, right? If I take that away from myself, u minus w dot, right? I no longer have write permission on this directory, right? Can I rename some other file? I'm going to try to rename it back to some file, right? It says it cannot, right? I can't rename some other file, permission denied, right? Why? Because I don't have write permission on this directory, right? And the file name is stored in the directory. It's not stored as something, it's not stored with the file itself. Right? And so that explains why these sets of permissions grant users slightly different capabilities. Right? Notice that there are other symbols that can appear, right? So you might have S, big S, T, and big T, but those permissions are beyond the scope of what we need to talk about. Okay, we'll skip number 2, the number of hard links. Okay, none of this stuff is super important. Okay. So how do you change file permissions? Yep, sorry, question.
Sorry, so if I have write permission on a directory,
yep.
I don't have executables
yep.
Permission, what can I do with it? It says I can't create anything on a directory if I don't have executable permission.
Yep. Okay, so let me go up one directory. Okay, so on the directory temp, right, I currently have read permission. I do not have write, but I do have execute permission, right? So let me strip off the execute permission. So u minus x on temp. Okay, so on temp, I can read the contents of the directory, right? I cannot write or execute to that directory, right? So let's see what happens. So can I list the contents of temp? Right? The answer is no, right? Sorry, the answer is yes, you can in fact list the contents of the directory. What does this notebook say? Read. Directory contents can be listed if execute permission is also granted. I guess that's wrong. Sorry. I just got to make a note to fix this. Although there's probably something subtle going on here, because there always is. Oh, sorry, let me quickly check. Okay, bear with me for one moment. Permissions, check. Oh yeah, there you go. So I guess the better way to put this is that if you don't have execute permission on the directory, you can see the files that are there, but you cannot get any information about the files that are there, right? And so when it tries to display any of the extra information about the file, it doesn't know anything, right? It knows what the contents are of the directory are, but it can't tell you anything about any information about the files that are actually there. So your question is, what can you do if you have, if you don't have execute, right? Oh, okay. So if I try to read a file that, do I have, oh, it's going to be funny now because I can't actually check what permissions I have there. So if you try to access a file that's there, right? Now, if I try to access information about the file that's there, right, that doesn't work either, right? I still need execute permission on that directory. Obviously, you won't be able to write to that directory either, right? So I won't be able to create new entries in that directory because I don't have write permission on the directory file.
So if I read and write, but I don't have executable, then I pretty much can't do anything with the directory.
The most that you can do is find out what files are there.
Okay.
Yeah. Okay, any other questions? Okay, so how do you change permissions on a file? So there's one command, it's called chmod, right? So change mode, which changes the permissions of a file. Right? Now the question is how do you specify the permissions? So if you actually look at the man page for change mod, you'll see that because there are variations on there are many variations of Unix, so there are many variations of permission symbols that this particular command understands, right? Because it sort of inherited this command from a bunch of different operating systems. And so the modern versions of chmod understand the symbols that are used by all of these variations, by many of these variations. Right? So there's two major forms of variations. There's one, you can define the permissions as what are called octal values. Right? And so this is a little bit easier to understand if I show it to you this way. All right, so imagine that we have read, write, and execute permission, right? And they can either be on or off. Right? So if you imagine binary 0 as being off and binary 1 as being on, right? Then if I write out the binary values of 0 through 7, right, I get the following bit patterns, right? 0, 0, 0. So that means off, off, off. Right? 0, 0, 1 means off, off, on. So that corresponds to execute permission. Right? 2 corresponds to 0, 1, 0. So that corresponds to setting the write permission as on. Right? 0, 1, 1. No read, but write and execute is on. Right? And so on and so on and so forth. Right? And so this is called the octal mode. So the octal value is just the base 8 value that corresponds to the binary value. Right? So these are just the numbers 0 through 7. Right? So if you use the octal value 0 for a class of users, right, that takes away all permissions for that class of users. If you use the octal value 7 for a class of users, that corresponds to all permissions for a class of users. Right, now remember there's 3 classes of users, so you specify 3 octal values. Right? So if you say 0, 0, 0, you take away all permissions for all users. Right? If you say 7, 7, 7, you set all permissions for all users. So for example, so what's going on here? So on file 1, right, I currently have those sets of permissions. Right? So to take them away, I just do change mod 0, 0, 0, and then the name of the file. Right? And you can specify more than one file, or a combination of file and directories, right? Or files and directories and directories, files in directories, right? And so on and so on and so forth. Right? So this one will remove all permissions from the file 1. Right? And notice that file 1 now has no permission set. Right? So no one can read, write, or execute that file. Right? If I want to give everybody or every user read, write, and execute permission on that file, right, I can use 777. Right? So what if I just want to give the user or the owner of the file all permissions, but take away permissions for everybody else? So that's just, that's just change mod 700 file 1. Right? So the 7, all permissions, right, for the user, right? 0 means no permissions for group, and the last 0 means no permission for other, right? And you can see that the user has read, write, and execute permissions, and everybody else is missing them. Right? And you can use any combination of octal values here, right, to set the various values. So I'm just going to pick some random numbers. I have no idea what these mean because I haven't memorized that table, and I don't expect you to either. Right? Right. So 436. So apparently that means read permission for me. Right. The 3 means no read permission, but write and execute permission for group. And the 6 means read and write permissions, but no execute permission for other. Right? Notice if you think about it for a second, these permissions don't make any sense. Right? Like it doesn't make sense that the user only has read permission, but everybody else has read and write permission. Right? And the group doesn't have read permission, but they can write or execute the file, right? Which is very bizarre. Right? So the permissions don't have to make sense, they just are. Right? And a lot of these combinations here don't make sense either, right? So 3 doesn't really make sense, right? It doesn't really make sense to not have read permission on a file, but you can write to it and execute it as though it were a regular program, right? That's strange. Right? Do I list the commonly used ones? I thought somewhere sorry, hang on, I just want to quickly scroll through. No, I don't have the commonly used ones. The ones that make the most sense here are 7, 0, 6, and possibly 5. I guess possibly 4 as well, right? Some of these other ones are unusual, right? But you can set the permissions to those values if you want to. Okay, so if you use the octal value, that sets the permission, right? If you use the alternate form, then you can either add a permission, remove a permission, or set a permission, right? And even though they sound like they're the same thing, they all have subtle differences, right? And so the octal values, if you use Linux a lot and you're often changing permissions on files, typically this won't be a regular user. It'll be someone like a system administrator who's administrating files for many different users, right? Then the octal values are super convenient, and you probably have them memorized. Right? There's only 8 of them, so it's not that hard. But, right? But an ordinary user who's not often changing permissions on files, right? It might be easier to use the symbolic form. So the symbolic form uses a symbol to indicate which class of users are you changing the permissions for? Right? So U means user, right? G means group, O means other, and there's an A as well, which is everybody, right? So the user, group, and other. Right? So that specifies which class of user you want to change the permissions for, and now you can specify whether or not you want to add a permission for a class, remove a permission for a class, or set the permission for a class. Right? So the equals here corresponds to what the octal form does. Right? The octal form literally sets the permissions to what you say. Right? But here you can add or remove a permission as well. And finally, R, W, and X, these correspond to the permissions that you want to set for the file. Right? So R means, sorry, not set. R means which of the permissions do you want to change. Right? So if there's an R, you want to change the read permission. If there's a W, you want to change the write permission. And if there's an X, you want to change the execute permission. Right? So if we start out with file 1 having no permissions, right, so let's use the first form, the octal form, to strip away all permissions. Right? Then I can add back read permission for the current user. Right? So change mod, so U for the current user. Right? I want to add, right? So plus read permission for the current user, right? And specify the file name. Right? And now notice that the current user now has read permission on that file. Right? If I want to take it away, right, it's a minus. Right? So I'm going to strip off the read permission for the current user, right? And again, no permissions. Right? If I want to assign the permission as R, right, and then I can use the equal sign. Right. So if you use the add, use the add permission, the add symbol, right, and the file already has that permission, then nothing gets changed. Right. If you use the minus symbol and the file already is lacking that permission, then nothing changes. Right? Assignment always will always attempt to set the permission. Yes?
Can you add like multiple permissions?
Yeah, I'm going to show you that in a second. So you can combine all this together, right? And there's many ways to combine them together, and I don't know them all. Okay, so here's file 1. The user currently has read. Right? So suppose I want to give everybody read permission. So change mode. So let me change, sorry, not everybody. Well, everybody's A, so A plus R. So A plus A equals R? Sure, let's do it that way. File 1. Okay, so I want to give everybody read permission on file 1. Right? Now everybody has read permission on file 1. Right? You don't have to use A. You can do UGO. Right? So user, group, and other. Right? Let's give everybody write permission. Sorry. Right? Now everybody has write permission. Right? Notice what's happened here though, right? So everybody had read permission here. Right? When I use equals, right, you are saying what are the permissions on that file. Right? That's the difference between equals, add, and minus. Right? So when you say equals, you are assigning the permissions, well, just W for everybody. Right? So everybody gets write permission, but that's all the permissions, those are the only permissions that they have. Right? So in other words, it also strips off read and execute permission for all the users as well. Right? So the difference is subtle, but it's important. Right? Well, it's important until you do ls minus l and then go ahead and fix it. Right? You can set permissions for different classes to different values. Right? So I want to do the user gets read write, comma. Group just gets read, other gets nothing. So if you put nothing, that means nothing. Right? So user got read write, group got read, and the group other got, the group other got nothing, receives no permissions. And if you go through the notebook, you'll see that there's some other examples that you work through. Right? So the symbolic form is slightly easier for the typical user to remember. Right? I would say most sysadmins, so most people who do this stuff regularly, are probably using the octal values instead. Right? Once you have the octal values committed to memory, it's relatively easy to use them. Okay, so there's how you change the permissions on files and directories in Unix or Linux. Right? I encourage you to go through the notebook and actually try the examples, right? And just fiddle with playing around with the permissions on files, right? You can't break anything. You can always restore the permissions to a file. So there's no way for you to break anything here, right? And of course, if you don't have access to a file because it's a system file, you won't be able to change the permissions on those files anyway.